जैसे कि हमने मोटर एफिशिएंसी के बारे में डिस्कस किया, तो मोटर एफिशिएंसी के बेस्ड जो भी डाटा है, पैरामीटर्स हैं, उनको कैसे कैलकुलेट करना है, लेट अस सी विद द हेल्प ऑफ दिस न्यूमेरिकल। यहाँ हमारे पास है a 7.5 kilowatt 415 volt 14.5 ampere 4 pole 50 hertz and 3 phase rated squirrel cage induction motor। इसके अंदर फुल लोड एफिशिएंसी दी हुई है 89% and power factor is given as 0.88 respectively. Now energy auditor measures what? He measures supply voltage as 410 volt. We are given rating as 415 volt and the current drawn by the machine as 9.5 ampere. Here we are having rated machine ampere is 14.5 ampere. So motor is working under rated. Power factor of operating condition 0.8 is given and supply frequency is 49.8 जो कि वेरिएशन है फ्रॉम रेटेड फ्रीक्वेंसी और आरपीएम ऑफ मशीन इज गिवन एज 1480 आरपीएम। हमें निकालना क्या क्या है? वी हैव टू फाइंड आउट पावर इनपुट इन किलोवाट, वी हैव टू हैव परसेंटेज मोटर लोडिंग एंड द स्लिप ऑफ द मशीन। तो सबसे पहले फॉर पावर इनपुट इन किलोवाट वी नो 3 फेज मशीन है, तो पावर इनपुट को हम ले सकते हैं बाय √3 VI cos phi। क्योंकि ये रेटेड वैल्यू से अलग है, लेट अस कैलकुलेट √3 into voltage is 410 measured, current is 9.5 amperes and power factor is 0.8. After solving this, we get the power input as 5.39 kilowatt. So this is actually utilized power. Okay, while the power input at terminal should be obtained from the equation this output divided by the efficiency of the machine. So 5.39 once divided by the efficiency which is given as 0.89, we get the power input at the terminals as 6.063 kilowatts. Okay, now we have to talk of slip. For slip we need to calculate first synchronous speed. We know the frequency, we know the number of poles. यहाँ frequency में variation है from 50 Hz that is 49.8. तो NS that is synchronous speed is given by 120 into F divided by P. जब हमने इसमें values रखी, we have to put the values of the operated, calculated, observed values, and number of poles is assumed as 4. So we get the synchronous speed as 1494 RPM and the actual speed is given as 1480 RPM. इस पर बेस्ड जब हम स्लिप निकालते हैं तो 1494 minus 1480 divided by synchronous speed calculated that is 1494 RPM. We get the slip as the percentage 0.93%. And now what is required? Third term we have to calculate percentage motor loading. Percentage motor loading is given by equation, and equation of motor loading is say actual operating load and it is divided by actual operating load that we have calculated divided by rated capacity of motor that we are already given and it is as in percentage we have to multiply it by 100. तो यहाँ पर हमारे पास rated capacity अभी हमने calculate नहीं की which is based on 3 phase है, we again have to multiply by √3. 415 volts था, current was given as 14.5 amperes and cos 5 is given as 0.88. Based on this, the motor rated power was 9.17 kilowatt, जबकि हमें actual terminal पर मिल रहा है 6.03, but that is after efficiency calculation. So here the input power available is 5.39. तो percentage motor loading जो आएगा, it would be 5.39 39 divided by 9.17, and this gives us motor loading as 58.7%. So you can observe the motor is actually rated for 415 volt 14.5 एम्पियर with 0.88 पावर फैक्टर, मगर जो ऑपरेशन हो रहा है दैट इज एट 0.8 पावर फैक्टर with 9.5 एम्पियर एंड 410 वोल्ट सप्लाई. सो रिड्यूस्ड, आपने मशीन का कॉस्टिंग तो पूरा पे किया बट यू आर लोडिंग इट ओनली टू दिस मच परसेंटेज. So this is derating and we are paying high for reduced services.